So we know we want to build a general purpose Internet of Things. Any physical object plug in. In the old days, you have smart grid. What that means, all those devices which control the power systems plug in. If you plug your phone, it won't work. Okay? And you have an environmental protection system. All the relevant devices can plug in. You can show this. So it's good to show the administrator did something for the city, but it's very, very costly and really cannot be commercialized. So here is the proposal, okay? I know the Hong Kong, the research competition pretty tough, and the same thing happened in US, etc. So we need to consider what's the idea, right? So we want a network which is connecting all the physical devices and the application together. Because it's called Internet of Things, so a trivial solution is why just use the Internet. Use the Internet, connect all the sensors. Use the Internet to connect all devices. Just let them run, because you say Internet is so great, let's just do it. What's the problem? Well, the Internet of Things really different from Internet because requirements different. For example, it requires information being transmitted in real time, right? Here you sense you have a fire, and you want to send an alarm signal to some device to put the fire off. So there is a delay you have to control. Otherwise, it didn't work. It asks for certain privacy security because a lot of information you gather is from physical world. This is relevant not only to your files, but directly relevant to your physical objects, which can be yourself or can be your friends. Should you look at this picture or not? Maybe intrude the privacy or not? Those kind of things. Also, Internet of Things require embedded computing. This is more or less from control theory. From control theory, we know very well. In order to make things controllable, you need to respond quick. Okay, you try to reduce the processing time, reduce communication delay. However, by end of the day, you have a limited computation power and also the transmission limit by speed of light. Okay? So in order to really meet certain requirements, the only way you do is computing closely to the object you want to control. So you cannot just say like today you have Internet of Things, you get a lot of information, say from CTU, and then send it to some government headquarters of control and send it back. In general, today, if you do email, those kind of things, okay, your email sent to the server, go to another server, do the kind of things. But in the Internet of Things, you need to have real-time computing, and which result is you actually have to do computing very locally. Also, things have to be scalable, right? If it's not scalable, then won't make large. As I said, the Internet of Things will be 2 or 3 orders bigger than current Internet. You have many things to connect. From a commercial point of view, we want a low cost and a quick start. Nobody wants to waste money. Everybody now wants something quick. Also, from business point of view, this should be marketable and profitable. If you cannot make money, even it's a great academic idea, you say on a paper, you never can be realized, become a product. Now, if we look at Internet alone, remember, proposal 1 is using Internet to act as Internet of Things. Then we know from a theory, I think many of my friends from computer science can tell you, we did a lot of works. The current Internet, from architecture and the protocol point of view, is not good for real time. It's not good for privacy or security. And embedded computing is just impossible. You cannot do any computing in the router, say, right? Nobody going to do that. But there's something good. The current Internet is truly scalable. The cost is very low. If you use Internet connect things, it's ready today, so don't do anything. But current Internet also make marketing and profit making very difficult, so that's all not good. So looking at this, certainly we know this is not a good idea. Actually, that's why people want Internet of Things. Otherwise, we don't have a talk today. You just connect everything into Internet. So next idea, we can go revolution. Oh, Internet not good enough. Let's just build a brand new network. Okay? We have InfoCom, we have SIGCOM, we have many technology developed. We can go back to IEEE transactions, look all the papers, how to do real-time communication, how to do embedded computing, how to guarantee privacy. Although all problems are still hanging there, I know many PhD students still write thesis, but I think the last 30 years we did a lot of those kind of things. Okay, all the technology more or less there, and too bad the guy built the internet didn't use them. Let's use them, do it. So that's the proposal 2, just construct a brand new network. Certainly, the problem you have, real-time, privacy, embedded computing, scalable, all become possible, right? Because now you just use the technology to do it, right? I work with Professor Ng, we have this theory and how to do real-time computing, embedded computing, those kind of things. The trouble really is, if you build a brand new network, remember we're asking a global network, connect device 2 or 3 order more than current internet. This would be a very heavy investment. The current internet was built gradually from 80s until now. This is about 30 years effort. Then you can connect every electronic devices. So this would be a very heavy investment, and certainly you won't see anything meaningful, say, next 5 years. So although this is a great idea, and it asks for a lot of money, but it's a very high risk. So again, we don't think this is a good idea. So now, use all the internet won't work. Develop a brand new network won't work. So what are we going to do? So we now propose a proposal 3 is a compromise solution, is to build a 2-layer system. Lower layer is using existing communication infrastructure such as the internet to communicate among the devices or servers. Upper layer try to do something which current internet has not been doing it. Therefore, we do this complementary approach. It's really not a revolutionary approach, but you can see it perhaps is more realistic. So if by doing this, then we know it's possible you can do real time. It's possible you can enhance privacy. It's possible we can do embedded computing. Scalability, low cost there because the low layer communication mechanism is there. Also, we can build in some mechanism to make sure people can make money. So after evaluate all the 3 proposals, proposal 3, I will say it's not great one, but certainly is a feasible one we should start with. So now let me follow along the proposal 3, tell you a little bit my team is doing. The team really made up by University of Macau, Tsinghua, Institute of Computing Technology in Chinese Academy, Tongji, and Eastern China Normal University. This is kind of a nice 7-3 team. We all have different contributions. So what I talk next is really all the team effort. So the name our network now is called the Winternet. Okay, we invent this name because my first initial is W. It's not a case. Okay, I really want to use a Chinese name versus where internet is English name. W is Wu. Okay, 物联网, so it's W. So rather than the P is physical, so we just try to teach American, British people Chinese how to say physical is Wu. So for the Winternet, also it's easy to pronounce. So what we do is we are using the internet as a low layer. On top of that, we're going to build another layer called the Winternet. Okay, so let me briefly introduce you how we do this layer and also tell you many open challenge problems. So at the upper layer, we call the IoT service layer. It goes like this. We have a lot of things called IoT server. You can consider those are kind of like a router. Okay, information will go from one server through something we call the link, go to another. And for example, you can have a sensor, then come to one IoT server, somehow being processed, and then go up further being processed, and some control command may be sent to here to device. If you further go up. The reason we have this kind of hierarchy is because embedded computing. So some computing belong here, some computing belong third layer, upper layer, etc. Right? Also in the network, we have a search services and a naming service. I'll come back to this a bit later. So the whole system look at this. So if you look at this, there are really three major components. How you build this IoT server, which can do some local computing, also knows where to send the information to. Now, how can you send the information in a secure, reliable way, make sure privacy and security and real-time guaranteed? Further, how can you do a search and naming? I'll come back to this later. This is actually a very, very challenging problem. How you do because in the internet, you have an IP address done with it. But should we use the IP address or use something else? So that's the three components. Server, the link, connections, and naming services. So let's talk about server. The server internal architecture, look at this. Information coming from the lower layer, we call the members. And they've been received by ports and get some local process, get some initial processing or filtering. Then they've been sent into something called the local processing unit. The unit actually is model driven, which have some physical knowledge. For example, this data represents the temperature, or this data represents the certain measurements, or measure in which way. After local processing, either certain command or control signal was sent down to the members, or the information we call image, the image from physical world, will be further sent up to other servers. At the same time, the local processing unit may also receive control information from upper layers, being processed, and decide how to distribute the control information to different members. So further break these pieces, then the information come in. We have a data fusion engine try to combine certain data together based on a data fusion model. And also a cyber control engine really try to monitor what the information really is and what we should do. And when it's proper, it will inform the control engine. Control engine on the other side first will receive a command from the upper layer, we call listener, basically try to keep listening what to do. And if necessary, when being triggered either this or this way, the control information is sent down based on certain control model. Okay? So this will be the more complex design. I don't think we need to go further. So what are we doing now is first we have a team, Macau and mainland universities, Institute of Computing Technology, Tsinghua, etc. We are making network. And the plan is in 18 months, we will make very first global Internet of Things. Okay? This never happened before. You heard a lot of Internet of Things going around, but if you ask them, say, is your network globally connected? Answer is no. Okay, this will be very first globally connected network. In US, we're connecting UCLA, Ohio State, University of Virginia, and UIUC. In Europe, we don't have much connection, but fortunately, Macau connect to the protocol very well, and the university portal actually pretty strong in real-time computing. So we're going to have a link over there. Of course, all these are upper layers. Low layer actually goes through the internet. So please don't be confused. I'm not lay the fiber over. Okay, this is thing we're using internet, connect them at a high layer in different places. We'll have different servers, and we'll further connecting different places. We also are talking to Taiwan National and some university local here. So I truly believe a Greater China region be connected to US connected and to Europe connected. This will be very first global test bed to test these kind of things.